GridSet's workspace consists of 3 views. The main view visualizes the individual sets, intersections, elements, and attributes. The set view enables the user to select and add sets from the set list. The detailed view provides more detailed information about the elements and their attribute values. The query view enables users to query, filter, and highlight elements and intersections. The user can add any set to the main view from the set list by dragging and dropping a specific set. Each element is represented as a small glyph with visual encodings. A square or circle shape can be used selectively for the glyph. A set grid consists of the element glyphs in a grid layout. The user can see more detailed information about element attributes from the detailed view. If the user selects a row from the detailed view, the corresponding element glyph is highlighted in the set grids. The user can hover over specific elements in a set grid. Details for the hovered element glyphs are shown in the detailed view. If the user clicks on a glyph, the clicked glyph is highlighted in a set grid and bookmarked in the detailed view. The main view also supports some navigation methods such as zooming and panning. In each set grid, elements are split into different subdivisions based on their exclusive intersections among the sets on screen. Elements in a subdivision represent a group of elements that are associated with specific exclusive intersections. Based on the added sets, their exclusive intersections are updated. The user can query and filter intersections by selecting a range of intersection degrees, which indicates the number of associated sets with the intersections. Based on this range selection, the corresponding visual links representing set intersections are displayed. The user can also define a logical condition for set membership based on and, or not operations to decide whether specific sets should be included in the intersections. Based on this logical rule, the user can highlight intersection links and subdivisions for the particular intersections. GridSet provides querying widgets for different types of attributes. For the numerical and continuous attributes, elements with specific attributes can be queried based on a desired value range by defining the maximum and minimum values using query sliders. Based on the dynamic query filter, we can visually highlight important elements in each set grid. The main view also includes the visual property menus that enable users to select visual mappings of element glyphs for their attributes. A set grid consists of element glyphs that can represent multiple attributes. Users can select how each set attribute can be mapped to different visual properties. Multiple time-varying attribute values associated with the same element can be visualized as a single sparkline image icon on top of each element glyph. Users can change the visual mapping at any point, thereby gaining different insights into the attributes. This data shows 4 different movie categories as sets. Each glyph in the set grid represents movie titles as set elements. We can assign different visual properties to different attributes for elements. In this example, the element size represents budget, the color represents the IMDb score, and the order of the glyphs are based on their gross earnings. The average of the attribute values in each subdivision can also be represented by the level of color saturation. Using direct manipulation of set grids, users can perform a set operation through a drag-and-drop gesture. We can drag and drop set grids onto the main view and overlap them. The user can then select a set operation from the menu. This shows a resulting set grid from the union of 2 sets. The user also performs an intersection of 2 sets in the same manner. We can also create a new set consisting of a specific group of elements that meets a user-defined range of attribute values and other set conditions. The values of attributes for the same element should be identical across different sets, but there's another type of attribute for which the value may change according to the sets. This type of attribute is called the set-dependent attribute. For example, each set represents a country and each element represents any war or conflict events involving multiple country sets. The war elements have set-dependent attributes such as military alliances or the hostility level of each country. The same war elements can involve multiple country sets, but each war can be represented with different colors or icons for each country based on each country's ally status.